All right, here is the 2008 FRQ for the AB exam, question number 6. So first, it asks us to write the equation for a tangent line at x equals e to the second. And so to do that, we need a point. We need the slope at that point. So I'm going to go ahead and find, I have the x coordinate of the point, but I need the y coordinate. So that's what I'm going to find first. Now, if you are not sure about simplifying that, just leave it as it is. It's not a big deal. But the ln and the e cancel out, and so you get 2 over e to the second. So the x coordinate, the y coordinate, they would not mark you wrong for not simplifying that. Next, we need to find the derivative, and they gave you the derivative. It's 1 minus ln x over x squared, which was very nice of them. So we're going to say the derivative evaluated at e to the second is 1 minus ln of e to the second over e to the second squared. So we have 1 minus 2 over e to the fourth, which is negative 1 over e to the fourth. So the tangent line would be y minus 2 over e to the second equals negative 1 over e to the fourth times x minus e to the second. All right, part B says to find the x coordinate of the critical point. And in case you forgot what that was, that's where the first derivative equals 0 or is undefined. And you get a little bit of a hint here because it says determine whether that point is a relative minimum, a relative maximum, or neither. This question is not really B and C are not really part of Unit 1, but we'll go ahead and do it as well as we remember, even though we're not there in the review yet. So this means we're going to say that the derivative equals 0 or is undefined. So you can do 1 minus ln x equals 0, x squared, actually I'm going to write this over here, and x squared equals 0. So this is where the derivative equals 0. This is where the derivative is undefined. I can see that that's happening at x equals 0. However, the original problem says to only consider x values that are greater than 0, and so I'm not going to be using that anyway. Okay, so over here I can add ln x to the other side. To get rid of ln, I can do e on both sides. So I get e equals x. And so I know that that's the value of the critical point of f. And now I need to determine if that's a maximum, a minimum, or neither. So I'm going to go ahead and draw my number line. I've got e right there. Now remember, e is 2.71, so to use a smaller number I can use 1. For a larger number I'm going to go ahead and use e squared because I plugged that in part A, so I might as well use it, I already have it. When I plugged it in part A, I could see that the answer was negative, so I already have that done. So now I'll go ahead and plug in 1. If I plug it into the derivative, I have 1 minus ln 1. Ln 1 is 0. So I have 1 minus 0 over 1 squared. So I've got 1 over 1 squared, which is just 1. That's positive. Okay, so I'm going to go ahead and say that there is a max. There's a relative max at x equals e. This is where f prime switches from positive to negative. And that's how I know. So that was part of my justify my answer. Remember, this work is fine. You don't have to scribble it out. It's not illegal, but this is not enough to explain. You have to use these words. So f prime switches from positive to negative. That's the calculus explanation. Okay, part C wants to know about the point of inflection. That comes from the second derivative. So going to go ahead and write down my first derivative again. F prime of x is 1 minus ln x over x squared. So the second derivative, we're going to do the quotient rule. So that's low d high. Derivative is 0. Derivative is negative 1 over x minus high d low. So the bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. I can definitely clean this up a little bit. So we've got negative x. If I distribute that 2x, I get 2x minus 2x ln x, and then I have the negative that I need to distribute to that. Both I'm going to take that out and take an x out on the bottom. Okay, so that is my second derivative right there. I know that the point of inflection is going to come from where the second derivative equals 0 or where it is undefined. Again, it's going to be undefined where x equals 0, which we said is not included in the problem. So I'm only going to look at the top. Okay. And I can go ahead. We know that the critical value, or not the critical value, but the point of inflection is there. But to make sure it's a point of inflection, we should make sure that it changes signs. So I'll go ahead and plug in 1 because that's easy, and e to the second is pretty easy as well. So if I plug in 1, ln 1 is 0, that part's going to 0 out, and I'm going to end up with negative 3 over 1 to the third, so that's negative. If I plug in e to the second, then the ln and the e are going to cancel out, and I'm just going to have a 2 there. I'm going to end up with a 2 times 2, and actually I really should just write this out. So those cancel. Negative 3 plus 2 times 2 is 4. And so I get 1 over e to the 6, which is positive. So that's definitely where the critical value is. Not the critical value, I'm sorry. The point of inflection. So find the x-coordinate of this point. Okay, and then part D is asking for the right-hand limit of f of x as x approaches 0. So I'm going to say the limit as x approaches 0 from the right of ln x over x. And the interesting part about this is that ln of 0 is undefined, and when you divide by 0, that's also undefined. However, they're not asking you to plug in 0, they're thinking about 0 from the right. So what I'm going to do is I'm going to think of these two pieces separately. And this is going to involve some illegal math. So when I'm done with this, I'm going to scribble it out for sure. But if you can picture a log graph, log graphs go like this. So I know that 0 from the right is going to be a negative infinity. This is why you know you're going to have to cancel this out in a second. So the top of the fraction is a negative infinity because 0 from the right, you've got your vertical asymptote that you're approaching, and you're going down as you approach it. On the bottom, 0 from the right would just be like 0.001. And so if you think about it, anytime you have a number divided by 0, you get infinity. If you have infinity divided by a 0 that's slightly positive, you're still going to get infinity. So this is negative infinity, but I would not write this in between step. I would scribble this out and just say this is infinity or does not exist. Okay, but I would say it's important to specify that it's a negative infinity and not a positive infinity.